Hi, everyone. My name is Derek Johnson. I'm a flight software engineer at RocketLab. And today I'd like to talk a little bit about some of the lessons that we've learned from a couple of lunar missions that RocketLab got to be a part of. So first off, a little background about myself. I was the Max flight software lead for the Blue Ghost Lunar Lander program. I also got to work on Lunar Photon, which is part of the NASA Capstone program. And I'm a sort of a max flight software expert at Rocket Lab, and I've contributed to 10 missions and counting so far. So, um, first mission that I got to be a part of, first lunar mission I got to be a part of, many firsts for Max Flight Software and first for Rocket Lab. It was the first lunar mission. And actually, I started at a company called ASI in Colorado, which was acquired by Rocket Lab in 2021. And it was actually acquired by Rocket Lab only 8 months before Lunar Photon launch. And so we had roughly 6 months to integrate ASI's Max Flight software with the Lunar Photon vehicle before launch. So it was a pretty aggressive schedule and pretty amazing project to work on to see it go from integrating software with a pre-built vehicle. It was far along in development cycle um, to launch 6 months later. So Lunar Photon had one payload. That was the Capstone satellite. Uh, it launched on an Electron rocket and did a whole series of orbit raising phasing maneuvers. And then finally a TLI translunar injection burn to put Capstone on its way to NRHO, where Capstone is still operating in NRHO, I'm pretty sure, and it's doing a technology demonstration for navigation within the NRHO orbit. Next mission I worked on needs no introduction. I'm sure everyone here has seen some of the amazing pictures and videos from Blue Ghost. There's a few people here that have worked on Blue Ghost, both on the Firefly side and the payload side. So congratulations to everyone. It was an amazing mission to be a part of, and and everyone online and back at ASI as well. Um, so the mission we landed in Maricursium. Operations were about 6 weeks from launch to landing. And then following 2 weeks of operations on the surface or one lunar day. Um, so the contract was awarded to Firefly to deliver 10 payloads to the lunar surface, and Rocket Lab was brought in as a supplier of flight software, GNC, and ground software, and as well as some solar panels on the lander itself. Um, so for Max Flight software, Blue Ghost was probably one of the most complicated Max Flight software missions to date. Um, it's a pretty big vehicle. I was always surprised when I saw it in person. It's like about the size of maybe a small car. So as you can imagine, a vehicle that big, there's lots of devices on that, lots of things to control, lots of payloads. So we wound up with maybe about 40 network devices, all controlled by Max Flight software. That included 10 payloads, and I'm ecstatic to report that all of the 10 payloads achieved all their mission objectives, got some amazing science data, some amazing footage. Really excited for everyone that's worked on that. Um, and then also there were 10 cameras, not counting the payload cameras themselves. So a lot of the cool footage that you saw on social media came from those cameras. And then we had a vision navigation system. That vision navigation system was responsible for assisting the navigation down to the surface during descent, as well as hazard avoidance. We had two radio interfaces on the lander. We had an S band and an X band, and I believe we've set a new record for highest data rate from the lunar surface of 10 megabits per second. So pretty happy about that. And we downloaded well over 100 gigabytes of data during the mission. So a little background on Max Flight Software. Max Flight Software is a commercial flight software platform by RocketLab. The first mission that launched, or the first Max Flight Software mission launched in 2007. There's been over 80 missions, over 80 successful Max Flight Software missions since then. And it's part of a larger suite of um, kind of the end-to-end software stack for a mission. So you flight software, mission simulation, ground software, mission planning, et cetera. So Lunar Photon, the reason why it was able to be developed so quickly was because we leveraged Max Flight software and everything that came with Max Flight software out of the box. And then we just had to make improvements to Max Flight software to support the lunar mission. And a lot of those improvements really set us up for success to then roll right into Blue Ghost. And so both Blue Ghost and Lunar Photon benefited from standard features of Max Flight software like attitude control and determination. Um, and those were, standard right out of the box Max Flight software features. But then we had to add a bunch of other improvements to Max to meet the requirements of a lunar mission. And I'm going to kind of go over some of the challenges and some of the improvements we made and lessons learned. So first off, one of the biggest challenges with lunar mission is telemetry. So Max Flight Software is traditionally LEO satellite flight software platform. So going in really high eccentric orbits, when you have low gain antennas in these highly elliptical orbits, your data rate is not consistent. So you have higher data rate at close to Earth, much lower data rate as you get farther out. And ground station passes are irregular. So the ground station pass can range from just a few minutes to many hours. And critical events can occur while out of contact. Sometimes you need to make a burn when you're not in ground station contact, or in Blue Ghost case, when you're behind the moon. Ground networks and ground software complications can lead to gaps in coverage. So ground networks are very complicated beasts, and when you're running operations that run 24/7 for many days in a row, there's bound to be times when you're troubleshooting ground network issues. And operators can't always anticipate what data will be important to them in advance. You can try your best, but sometimes during the mission, as the mission goes on, what you're interested in can change. So with all those challenges in mind, we employed some strategies to address these. We've improved telemetry budgets within Max, telemetry aggregation, telemetry recording, multiple telemetry streams, and prioritization of that data. And I'll cover some of these here. So I really love this chart here, over here, because it really kind of shows the scale of the problem. So what you have down here, this is from the LGA. So this is our S-band data rates from the spacecraft to the ground. And you can see when we're close to Earth, we have really significant data rate to the ground. And then when we're in our highest orbit, or when we're in a safe mode, when we're just transmitting the most reliable signal, you can see that our data rate is minuscule. And then to put it in even more context, it's kind of funny. Down here, this is S-band data rates. This same chart up here is the S-band data rates compared to the X-band. So you can kind of get a picture for how, how much of a fire hose the X-band radio is, and why it was so amazing to have that. And that's how we got a 100+ gigabytes of data down to the ground. So one of the main improvements to Max is telemetry budgeting. So If you think about Max is a series of components within Max Flight software that is generating data at relatively high data rates, and it's a lot of data. It's tens of thousands of data points generated many times a second. Obviously, it'd be great if you could get all of that to the ground, but as you can see from that chart there, there's going to be times where you're not getting even a fraction of that to the ground. So what telemetry budgets allows operators to do is go and pick and choose the data that they're interested in, and then create a budget from that data, run it through our tools to then go and say, are you over budget? Are you under budget? How much margin in your budget do you have? And it allows operators to quickly iterate and quickly change. So if they need to, if there's one subsystem, like let's say prop during a burn, if they want their data rate really fast, while another system, maybe thermal, they don't care if they get it that fast, maybe once a minute is fine for them. You can kind of make those trades and say, okay, this subsystem gets their data at a high rate, this subsystem gets their data at a lower rate, and then run it through the budget tools, and it'll spit out an answer and say you're over budget and you still need to find some telemetry that you need to tweak, or it'll say you're under budget and you have this much margin. And so we build those budgets for the different data rates that we have throughout the mission. So we'll have typically like a safe mode budget, and then we'll have budgets for different phases of the mission. We might have a budget for burning and a budget for descent. And so you have these pre-planned budgets that you can just command the spacecraft to go into that mode to send that data. But then you also have the flexibility to change the budget as needed. And another tool that we added as part of that is telemetry aggregation. And so as you can imagine, you got all these different components within Max. They're all generating telemetry, but they generate telemetry in a packet. And sometimes you might have a packet of data, and operators might only care about one data point within that packet. So it would be really inefficient to send that whole packet down to the ground just to get the one data point that they're interested in. So what aggregation does is you can go and pick and choose individual data points from all the different packets and put them in an aggregated packet. And now you're only sending what operators are interested in at the rates that they want to get that data. And you can also do really clever things with telemetry aggregation. For example, if you have a whole bunch of power switches that are either on or off, and you want to send that telemetry down, rather than sending a byte to say on or off, you can use the telemetry aggregator to say store all these power switch things in a single bit in a bit field. And you can even expand that to, like, if you have an enum that has 4 potential values, you can put that in a 2-bit bit field. And the aggregator does all that automatically. So it makes it super easy for operators to just say, I want this data, I want it at this rate, put it in a budget. Is that possible? Then another feature that we added or really expanded on is telemetry recording. So we added a mechanism within Max Flight software to record any telemetry that operators want to record at whatever rate they want to record it. And this became extremely useful. So we, during burns, we would ratchet up the record rate of like prop telemetry, things like we want to see how the burn performance was. So we'd record that data at a really high rate, but we'd also configure it to record everything at a low rate. And that was really nice and proved extremely valuable, because you don't have the bandwidth to send everything to the ground, as you can see from the charts there. And so if you can't send everything to the ground, you can at least record everything. And then later on, if an anomaly happens or some behavior doesn't quite match expectations, and you want to go back and you want to look at something after the fact, it's recorded, it's on the spacecraft. So then you can use your little bit of bandwidth to then go and say, well, now this data that I thought wasn't interesting, now it suddenly is interesting, and I want this data. So then you can go and query the recorded data, kind of like querying a database. And so you can also pick and choose what was recorded not just dumping the whole, all of the recorded data, but you say, I want this particular packet that's been recorded, and send just that to the ground. And that was extremely powerful, and maximized our use of very limited bandwidth. And then finally, we added telemetry, a whole lot of telemetry stream features. So we had S-band, X-band, we had real-time telemetry that we budgeted for. We had event-driven telemetry. We had file downloads, that kind of thing. So all these streams are competing for the pipe. And we added a whole bunch of features to support that at different priority levels. And then also to be able to switch any of those streams from interface to interface. So we could use all S-band, which we typically did in transit unless we were slewing to point the X-band. But if we had X-band, then move those streams to the X-band, because now you've got this massive pipe and you can really send a lot of data down to the ground. Another feature of max flight software that we used extensively on both lunar missions is the Flight Jazz sequencer. Sequencer is a really powerful onboard tool to enable sequencing commands and autonomy on board. And it kind of goes way beyond just sequencing commands. It's almost like an interpreted language. It supports telemetry lookups, math functions, string functions, conditionals, loops, etc. So you can really make some powerful automated features within MaxFlight software that don't actually require a compiled binary to run. So what that enabled us to do is we were able to update automated features of Max Flight software at runtime. So if there were automated functions implemented in sequences, for example, sequencing complex events like preparation for burn and then the burn execution, or payload operations, if we needed to tweak those in flight, it was just a matter of updating that Flight Jazz sequence as opposed to doing a full flight software update. So that proved really powerful. And then Flight Jazz can also be used to simplify and reduce operator workload. Rather than sending command after command, you put it in a Flight Jazz, you put it on the vehicle, and then the operator sends one command to start the Flight Jazz. And so we also use that for automated responses to events like fault responses. And then, so if a fault starts happening, if an anomaly starts happening and Fitter is responding to that fault, we could then go and tweak the response to that fault if we deemed it necessary. And what was nice about that is, since it was Flight Jazz, it was, again, a really easy update process. And so, yeah, Flight Jazz gave operators the flexibility to quickly modify flight software and adapt to dynamic mission needs. So we in addition to just configuration and Flight Jazz, which was the majority of the updates that we did during both missions, and those updates were done at runtime. In other words, Max Flight software was running the entire time we were doing those updates. But in addition to that, we did have the capability to do binary updates, as well as firmware updates of the different avionics boards on the vehicles. And having the capability to update basically everything on the vehicle is super critical, especially a new vehicle on a mission that has a lot of crazy requirements and a lot of different phases. You're bound to run into some things that didn't behave exactly how you anticipated they would, or some things that you need to tweak. And having the capability to make updates on orbit is really critical to success. So on the Blue Ghost mission, we updated config and Flight Jazz 26 times during a 2-month mission, which is kind of mind-blowing. It's like one every other day. Now, a lot of those updates were anticipated. So for like things like maneuver prep and scheduling of automated operations. So things that we knew we had to do before we even launched, but we didn't quite know exactly how we were going to do it or the timing of things. And so that was the majority of the updates, is just uh, uploading those maneuver prep and scheduling automated operations as the mission progressed. And then we also did some updates to address anomalies or tweak subsystem behavior. A few updates to change like set points or fitter thresholds. And we even added a few things to like simplify operator workload. Things that we discovered as the mission was ongoing was super tedious, or um, we wanted to implement some automated logic that we wanted to do during a blackout. And so we could upload new flight jazz in that case to then go and do those automated features. So I guess kind of the lesson here is that flight software is not done until the last bits have been received and all payloads have met objectives. So flight software was still very involved through the whole mission operations. Um, and having the modular and configurable nature of a flight software framework like Max really enabled all this to make all these updates possible. And the vast majority of these updates were done at runtime, so it didn't impact any ongoing operations, which is amazing. Um, so Blue Ghost had a ton of payloads, and we quickly realized that to interface to that many payloads, we had to standardize the interface. So we developed a standardized modular max flight software components for those payloads. And components were highly configurable to meet the needs of all the different payloads. And I think one thing that was really key to our success is that we gave emulators to all those payload groups that would run the full software stack. So they would run max flight software, the same flight code that they would run on orbit with max GDS, the ground data system, the ground software, which is the same software that would run during operations. And it gave payload teams the capability to test with the full flight software stack with their payload and get used to what it's like to operate a payload through Max Flight software. And we gave the payload teams emulators on a Raspberry Pi, I want to say almost like 2 years in advance. So really gave payload teams I just want to play this video here because it is super cool. Geeking out over some of these amazing payloads. Drilling on the moon. This is the Lister payload. All right. So one thing that I'm sure is everyone knows here is that the key to mission success is test-driven mindset. So Max Flight Software has Max Flight Software has a simulation tool called Odyssey. Odyssey, you can see on the diagram here, you can test your flight software algorithms. You run the same exact flight software, but instead of the outputs going to physical actuators, they can be fed into Odyssey, into the Odyssey models, where the Odyssey models then feed back into your sensors, which then go through your flight software again, and you can see how that goes on and on. But what that allows you to do is put your actual flight software in the loop and run it with your models. And you can even do that on the flight processor itself, just run this all in a loop, or you can do it externally and have real physical actuators and sensors in the loop. So every flight software change had to pass these automated mission scenario testing. We set up CI/CD And you can kind of see down on the bottom right there, that was just some telemetry from the CI/CD pipeline of these Odyssey simulations, kind of showing GNC accuracy of landing, like horizontal and vertical velocity and that kind of thing. We could track all those statistics from all the different runs. And then it was very obvious when a change would make a breaking change, and you could see it in the data. I'm running out of time here, so I want to talk about lessons learned real quick. While I do that, I'm going to play this guy. Just a really cool video from Scalps showing the landing there. So after all this super successful mission, there's still plenty of lessons learned in the mission. So what are the things that I would do differently next time around? Emulation of hardware more early on in the program is super valuable. So if hardware is always hard to come by, it'll be in development sometimes longer than you expect. And then when you get the hardware, it's a hot commodity and everyone wants it. So if you can emulate that hardware, you can test early on, you can test more frequently without running out of resources. And then time spent on test automation is generally worth it. Your future self will thank you when a critical issue is caught by automated testing. And here's a big one for me. I think it's really important, and I didn't really hear a lot of this in some of the other talks, is putting an emphasis on operations is really critical. So think about when you're writing your flight software, not just does your flight software meet the requirements, but if you gave your flight software to operators, does it meet all their needs? Is it like you wouldn't want to write flight software that you wouldn't want to fly yourself? So it needs to not only meet requirements, but be easy for operators to use and maintain. And then just getting flight software involved in ConOps discussions early on in the program. So late stage changes are costly and risky, and you never want to get yourself in a situation where AINT testing or mission rehearsals are showing that you need to make some changes, and you don't want to be having to make changes that late in the game. So yeah, with that, I'll if there's any questions.
Thank you, Derek.
Yeah.
I think we are way over time, but we'll take one question and then you can follow up with the rest online, please. Thank you.
Thanks. It was a really great talk. One of the things I was thinking about for your telemetry section, you talk about kind of how operators have the option to request high cadence telemetry in the future. Do you ever consider like setting up a system where it's basically constantly recording high cadence telemetry in the background and only storing it for maybe a day or so? And so if you saw anomalies, you could kind of request that historical high cadence telemetry, and it would only downlink it if there was an anomaly or if you saw something like that.
Yeah, and that's actually what we did. Mainly, if we didn't record everything at the rate it was generated because of flash requirements, flash volume, and also flash write speed. But if there's certain data points that, like say with a prop system or GNC, that you want recorded at a higher data rate, you certainly can do that, and that's what we did during the mission.
All right, thank you, Derek. There are follow-up questions. Please follow up with on Slack. Thank you so much.